Today we're breaking down cables that move data at the speed of light. Literally. Well, not literally, but it's pretty darn close. We're talking about fiber optics, multi-mode versus single mode. Fiber optic cables use light instead of electricity in order to transmit data. Inside the cable are tiny glass fibers that carry light pulses that represent digital information. This allows for faster speeds, longer distances, and no electrical interference. Now, imagine that you're at the Grand Canyon shouting. Your voice, the sound waves, will get weaker throughout the distance. Now, imagine using a laser pointer. It's going to be straight, fast, and clean. The fiber optics is the laser pointer of networking. Instead of sending electricity down a copper wire, it sends light pulses in a glass tunnel. Now, fiber optics rely totally on internal reflections. Light beams bounce in a tiny glass core that's trapped inside a reflective cladding layer. What is a cladding layer, you ask? Well, a fiber optic cable has three main parts. The core, which is the glass pathway where the light travels. Cladding, which surrounds the core and reflects the light back in. Coating/jacket, protects against moisture, bends, and breaks. Now let's talk about single mode versus multi-mode, and try to stay with me. I'm going to try to make this as clear as possible. Single mode fiber, or SMF, has a tiny core, approximately 9 microns. Uses laser light to transmit data in a single path, ideal for long distances, up to 100 plus kilometers. Common in ISPs, data centers, and enterprise backbones. Multi-mode fiber, or MMF, has a larger core, approximately 50 to 62.5 microns, uses LED lights, multiple light paths or modes, perfect for short distances up to 2 kilometers max. Used in LANs, campus networks, and server rooms. Now, fiber connectors and colors can get very confusing, but for right now, just know that yellow equals single mode, OS1 or OS2, aqua or orange equals multi-mode, OM1 or OM5. Common connectors are LC, SC, and ST. And there's a few other things that go along with that, but don't worry, we're going to cover this literally in the next video. So what are some advantages of using fiber? One, it's incredibly fast, like insanely fast. I'm talking 400 gigabytes a second or more fast. The distance is longer, like 100 times further than anything copper could ever even think about doing. It's electromagnetic interference immune. And also it's extremely secure because it's very hard to tap into it physically. Drawbacks: it's way more fragile, it's way more expensive, and it's trickier to terminate those connections than it is copper. Also, you have to be very precise with the alignment so that way the light can transmit cleanly. To recap, fiber optics uses light instead of electricity in order to transmit data. It has huge speeds and range, connecting continents, data centers, and it's probably the backbone of your ISP's network. Single mode is for long distances, and multi-mode is faster, but it's for short distances. Okay, I hope you found the video useful and informative. If you did, please go ahead and smash that like button for me. Subscribe so that way you don't miss out on further content, and work with what you got to build what you need, and I will catch you in the next one.